Greetings and welcome. This is Dr. BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In this session, we will be learning about the definitions and terminologies in impulse momentum and mechanical vibrations. Let us start the problems as well as the definitions. So, first one is, what is impulse? The definition says, the product of force and time is called as impulse. So, in engineering mechanics, the concept of force is involved in each and every system, and we are going to solve the field problems. Wherever the force is being acting, we need to define 4 characteristics for completely showing a force. As we have discussed in our first module, the characteristics which are needed to be shown for a force for completely defining it are magnitude, direction, point of application, and line of action. So once we define all these 4 characteristics, the force is said to be completely shown or completely defined. Now, coming to the impulse part, the product of the force and time is called as the impulse, wherein for clearly understanding this, we can discuss about the Newton's third law, where the Newton's third law says, for each and every action, there is an equal and opposite reaction. That means, for every action that we do, there will be a reaction. Maybe if we throw a ball against a wall, then the ball will be revert back to the person with the same speed which the ball impacts the wall. So, in this consideration, we can understand that the time to which the ball is getting in contact with the wall plays a major role. That fraction of time where the deformation of ball or the wall acts or happens is termed as the action time. And the reaction to this task or action would be the force that is applied opposite to the application of the force by ball or the wall. That means the force that is applied by ball onto the wall will be acted upon reverse direction from the wall upon the ball. Then the ball will again thrown back from the impact and the ball comes back to the person. So the whole task which is being acted here is termed as the impulse. The force with which the ball is acting upon or the ball is thrown upon the wall, that will be directly proportional to the wall's force that is being acted upon the ball. In this way, the time that is taken for the ball to get in contact with the wall and to detach, this total time will be considered, and the force which is acting in this total scenario or case, that is the ball getting touched with the wall, will be considered as the force in the system. So that force and the time, the product is taken and it is termed as the impulse. So the term integral 0 to t r into dt is called impulse and units are Newton second. Here, if you observe, this R would be the resultant of all the forces that is acting in the system. Resultant of all the forces that are acting in the system, and this is the time to which the forces are being acted. The time to which the forces are being acted. And the integration term would be the starting position to the end position, that is time from 0 to t. So, integral 0 to t r dt would be the impulse. So, the force into time, the units would be Newton for the force and seconds for the time. So, the units for the impulse are Newton second. Next one is, what is impulse momentum equation? So, we all know that the momentum is the term considered with the quantity of matter and the velocity with which the object moves. So the quantity of the matter of the object and the velocity that is involved in the system would be taken as the consideration, and the product of these two terms, that is mass and velocity, would be the momentum. Now coming to the impulse momentum equation, the impulse momentum equation is represented as integral 0 to t r dt is equal to change in momentum, that is final momentum minus initial momentum. That means mv minus mu. So the impulse term, that is product of force and time, would be equal to the change in mass into velocity. So that overall this equation is given as impulse momentum equation. Next, what is conservation of momentum? So the principle says, the principle can be stated as the momentum is conserved in a system in which resultant force is zero. So as per our discussion in the previous thing, that is Newton's third law, we have seen the action and reaction terms, wherein in a system, when action is happening, then reaction will happen. So when the whole system is considered, that is the example which we have discussed about ball and the wall, there are two cases. One is the ball getting into contact with the wall, that would be the action case, and the wall that is acting the opposite force onto the ball will be considered as the reaction. So that would be reaction case. So when the action and reaction both are considered at a time, that means the total system is considered completely. The action part of the system and the reaction part of the system, both cases are considered in the system, then we can say that the momentum or the energy is conserved. Here in this case, the momentum is conserved. So here we can understand that the resultant force would be zero. How we can say that? As we know that the action and reaction, after the action and reaction are happening, we understand that the resultant, all the forces acting in the system, will be neutralized. If you consider only the action part, you can observe the force. If you consider only the reaction part, again you can observe a force. But when action and reaction both are considered at a time, or the total system is considered, then the forces that are acting in the system gets neutralized. That means there won't be any resultant force. So if in a system there is no resultant force, then we can say that the momentum is conserved. So as per the principle, it can be stated as the momentum is conserved in a system in which resultant force is zero. Next one, define impact. So the definition is given like this. A collision between two bodies is said to be an impact if the bodies are in contact for a short interval of time and exert very large force on each other during this short period. We can take a best example of two cars getting collided or getting accident. Two cars which are involved in an accident. So let us say one car is coming from left side and another car is coming from the right side. This is car A and this is car B. And this car is coming in this direction and this car is coming in this direction. When they both come and gets collided at a point, let us say that is the point here, both gets into contact with each other and collides here. Here what happens, for a short interval of time, very, very short interval of time, maybe 1/10 of a second, let us say, or 1/5 of a second, they are getting in contact with each other. And in this 1/5 of a second, what happens, this car A, the collision point or the contact point will get deformed, gets compressed. And this car B also, the front side of this car again gets deformed after getting into contact with each other. In this deformation time, the forces will be exerted by one car onto the other in a direct manner. And those forces will be a very large force that are getting in contact with this or involved in this collision, and one car is applying a greater force onto the other car. So because of this, the deformation is happening. The deformation of the car is happening. So the energy, whatever kinetic energy that is involved in this scenario, that energy will be converted into the deformation of this thing, deformation of this object, the car, as well. It will be exerted in the form of great sound energy, and as well as the heat energy. After the collision, we can hear a lot of sound, as well as some of the heat will be generated because of the collision between the two bodies. So in this way, this scenario is called as the impact. So clearly stating the definition of the impact can be given like this. A collision between two bodies is said to be an impact if the bodies are in contact for a short interval of time. Definitely for a short interval of time, maybe 1/5 of a second, maybe 1/10 of a second, both the bodies will be in contact with each other. For a short interval of time, both bodies will be in contact with each other. Then they exert very large force. On each other during this short period. This case would be termed as the impact. Now, what is the line of impact? So it is defined as the common normal to the colliding surface. That means the previous example which we have considered, this is car A coming in this direction and car B coming in this direction. So these directions in which both are traveling in a straight line, this line can be considered as the line of impact. That is the common normal. The direction lines are in common form, common normal. Similarly, if the body A or car A is traveling in this direction and car B is traveling in this direction, and after a small interval of time, they will be getting in contact with each other and they get collided here. So this would be the line of impact. So as per the definition which we are considering, it is defined as, the line of impact is defined as the common normal to the colliding surface. Now, what is direct impact? If the motion of the two colliding bodies is directed along the line of impact, the impact is said to be direct impact, right? So in the previous example which we have taken, the first case, the two cars A and B traveling in the same line, that is getting in head-on collision, both the cars are traveling in exactly same opposite direction. That means in a same straight line. So this would be the direct impact. So in that example, both the cars are traveling along a line which are getting into contact with each other, and this collision is happening in a head-on way, and the traveling direction of both the cars are in opposite direction in a straight line. So this type of impact can be considered as the direct impact. So the definition says, if the motion of two colliding bodies is directed along the line of impact, the impact is said to be direct impact. Then what is oblique impact? Then the second example which we have taken, car A is traveling in a straight line like in this fashion and car B is traveling in this fashion. So both are getting and colliding at this point here. So here the directions are different. one car is traveling in straight horizontal direction, another car is traveling in an inclined direction. Here, the traveling directions are different, but they are getting and colliding at one point. So this type of impacts are called as the oblique impact, wherein if the motion of one or both of the colliding bodies is not directed along the line of impact, the impact is known as oblique impact. So generally, when a car is taking a turn and suddenly bus or any truck are already traveling in a highway, gets collided with the car which is taking a turn. So this type of accidents can be called as the oblique impact. That is an example. Then what is central impact? So the definition says, if the mass centers of colliding bodies, are on the line of impact, the impact is called as central impact. So according to the definition, we can understand that the line of impacts are passing through the centroids of the objects. Mass centers, nothing but the centroids of the object or center of gravity of the object. If the mass centers of colliding bodies are on the line of impact, like our first example, both the cars traveling in the line of impact, head-on collision, that type of impact is called as the central impact, wherein the mass centers are lying along the line of impact. Then what is eccentric impact? The definition says, if the mass centers of one of the colliding bodies is not on the line of impact, the impact is called eccentric impact. So best example for this would be ball getting hit by a cricket bat. When playing cricket, ball comes in one direction and the batsman holding the bat will hit the ball in one direction. So the mass center of the ball as well as the mass center of the bat will not be on the same line of impact, but the collision happens. So that would be our best example for the eccentric impact. Next one is, what is Newton's law of collision of elastic bodies? So first we can understand what an elastic body is. Elastic body is the property, the elasticity is the property of the material to which when it is deformed, that means some deformation is been created in the material, then it will be reverting back to its original shape. So when this is happening, what would be the characteristic of the material that we are going to discuss? The question is, what is Newton's law of collision of elastic bodies? And the statement says, this law states that when two bodies collide with each other, their velocity of separation bears a constant ratio to their velocity of approach. So that value in a mathematical form, it is given as V2 minus V1 is equal to constant into U1 minus U2. Here, V1, V2, U1, U2 are the initial and final velocities of the two bodies, any two bodies that are moving. So U1, V1 are the initial and final velocities of body 1, and U2, V2 are the initial and final velocities of body 2. So when you mathematically solve this, V2 minus V1 by U1 minus U2 is equal to constant. So as per the statement, we can understand that the two bodies collide with each other, their velocity of separation bears a constant ratio to their velocity of approach. So this constant is the coefficient of restitution. So the constant which is defined in this statement is called as the coefficient of restitution. It is denoted by the small letter E. It is denoted by small letter E, and E is given as V2 minus V1 by U1 minus U2, wherein the differences, the final velocities difference by the initial velocities difference will be considered as a constant, and that constant is termed as the coefficient of restitution. Coming to next one, define coefficient of restitution. So as per the equation we have just seen, the coefficient of restitution for two bodies moving and colliding with each other is defined as the ratio of velocity of separation to their velocity of approach. That is given as E is equal to V2 minus V1, which is the velocity of separation. That means after collision, the velocities of the two bodies, and U1 minus U2, that is the velocity of approach. That means before collision, the velocities of the two bodies. Next one, what is recoil of gun? It is defined as when a bullet is fired, it leaves the gun with a certain velocity and gun moves backwards. That means for the action that is happening, that the bullet is coming out of the barrel or the gun, the reaction of this thing would be the movement of the gun towards the opposite direction of the exit of the bullet. The backward motion of the gun is called recoil. The backward sudden impact. Because of the impact that is happening, the firing of the bullet, because of that impact, the reaction which is happening there in the case is the gun is moving backwards. That is opposite direction to the direction of the bullet movement. So that movement is called as the recoil. So when a bullet is fired, it leaves the gun with a certain velocity and gun moves backwards. The backward motion of gun is called recoil. Next one is explain the term vibration. So if the body is given a small displacement from the position, the initial position which we can say, or a state of rest, we can consider it as state of rest, a force comes into play which tries to bring the body back to the equilibrium point. So what we are doing here, we are creating a disturbance. For a stable rest body, what we are doing, we are creating a disturbance. We are incorporating a force into the system and we are trying to move that body. So a force comes into play which tries to bring the body back to its normal point. That means it is continuously moving to and fro, and one force that is coming into the picture, and the equilibrium state of the body is again obtained. So giving rise to the oscillations or vibrations. So this will create the to and fro motion of the object. And keep in mind that this to and fro motion of the object will definitely be the property of the material, which is the elastic property. And because of this elastic property, once the body is getting disturbed and it moves to some distance, again it will try to come back to its normal position because of the property of elasticity. So the term vibration is defined like this. If the body is given a small displacement from the position, a force comes into play which tries to bring the body back to the equilibrium point, giving rise to the oscillations or vibrations. Next is, what is simple harmonic motion? So this is one of the application of the vibration of the body. It is given as oscillatory motion under a retarding force proportional to the amount of displacement from an equilibrium position is called simple harmonic motion. So this is a motion of the object that is happening, the oscillatory motion of the object that is happening under the retarding force. That means because of the elastic property which we have discussed, the retarding force will be incorporated into the system and the object will be displacing. So the force, the retarding force would be the proportional to the amount of displacement from an equilibrium position and is called as the simple harmonic motion. So the definition of simple harmonic motion can be given as oscillatory motion under a retarding force proportional to the amount of displacement from an equilibrium position. So it is called as the simple harmonic motion. Next one is describe longitudinal waves. The longitudinal waves are waves in which the displacement of the medium is parallel to the direction of propagation of the wave. So whatever displacement that is happening in the medium, that would be parallel. So the medium is parallel to the direction of propagation of the wave. So longitudinal waves are waves that are going to be considered in which the displacement of the medium is parallel to the direction of propagation of the wave. Next one is, what is damped vibration? So the oscillatory motion in which the amplitude decreases continuously with the passage of time is known as damped oscillation. So the amplitude decreases continuously. When an object is taking an oscillatory motion and the amplitude decreases continuously with the passage of time, as the time goes on, the amplitude, that is maximum distance the object is moving from the equilibrium state, that distance gradually it gets decreased. It is called as the damped vibration or damped oscillation. So many a times, whatever the automobile's suspension systems that are being made, so that suspension system is being taken into consideration with this damped vibration, the damped oscillation. Once the vehicle hits a bump, then the vehicle's suspension system immediately after the impact, that means the collision or the bump, when it gets hit by a bump, the vehicle stability will again comes into equilibrium state as soon as possible. That means continuously the movement of the spring or movement of the suspension should not be there, so that the comfortness of the passenger is increased. Hence, the damped oscillations will be considered when the uneven movement or the oscillation of the springs of the suspension system is happening. The engineers will see that the movement of that spring or suspension will get to a neutral state or get to a equilibrium state as soon as possible. Maybe within 2 or 3 movements of the vibrations or the oscillations, it gets to a neutral state. That is the damped vibration. So the oscillatory motion in which the amplitude decreases continuously with the passage of time is known as damped oscillation. Next one is, what are forced or driven vibration? So all free oscillations eventually die out because of the ever-present damping forces. However, an external agency can maintain these oscillations. These are called forced or driven oscillations. That means if the oscillations that are needed continuously, if we are not going to apply any force into the system, then eventually the vibrations or oscillations will get off. So if as per the requirement, if the oscillations are needed continuously, what we need to do, we should implement some force into the system. And because of this implementation of the force, the oscillations are happening, and these oscillations are considered as the forced vibrations or driven oscillations. So all free oscillations eventually die out because of the ever-present damping forces. However, an external agency can maintain these oscillations. These are called forced or driven oscillations. Next is, define the term degree of freedom. So it is defined as the minimum number of independent variables required to define the position or motion of a system. So the position of the system or the motion of the system are being defined here, whereas the minimum number of independent variables required. So for defining a system, the minimum number of variables that are required, this is called as the degree of freedom. So the definition says it is defined as the minimum number of independent variables required to define the position or motion of a system. Next one, explain the term resonance. So when the driving frequency is equal to the natural frequency, the oscillations can be large. This is called resonance. So the greater will be the amplitudes when the driving frequency is equal to the natural frequency of the object. So whatever frequencies that are implemented manually into the system or onto the object, if that vibrations that are being created are equal to the natural frequency of the object, then the oscillations will be large. That means the greater amplitudes we can experience. Hence, this is called as the resonance. The definition is given as when the driving frequency is equal to the natural frequency, the oscillations can be large. This is called resonance. Next, explain the term wavelength. A wavelength is a measure of distance between two identical peaks or crests. These peaks and crests we can observe in the waves that are being formed for any type of vibration. And these waves from the neutral position or the equilibrium position, the maximum amplitude of the object that is taken, it will be considered. So, two identical peaks or crests distance is measured, then it is called as the wavelength. So, the wavelength is a measure of distance between two identical peaks or crests. Next, define frequency. Frequency is the number of occurrences repeating event per unit time. So, the number of occurrences that are repeating event, number of occurrences, that means the movement, to and fro motion continuously happening per minute or per unit time, it will be considered as the frequency. So, whatever oscillations that are happening in a system for an object, those oscillations, if we count down for time, per unit time, then it is termed as the frequency. And frequency is denoted with the letter efficiency or eta. What is pendulum? So the definition is given like this. A pendulum is a weight suspended from a pivot so that it can swing freely. So when a pendulum is displaced sideways from its resting equilibrium position, it is subjected to a restoring force due to gravity that will accelerate it back towards the equilibrium position. So here, when the pendulum is moving to and fro from the extreme position from one side to the extreme position to the other side, the gravitational pull comes into picture, and when this pendulum reaches the maximum extent extreme position, gravitational pull will make the pendulum to move again, come back to the equilibrium position. So, and this acceleration will make the pendulum to go again to the other side of the extreme position. So, with this, the movement of the pendulum happens. That means the acceleration makes the pendulum to move in the to and fro direction. So, a pendulum is a weight suspended from a pivot so that it can swing freely. When a pendulum is displaced sideways from its resting equilibrium position, it is subjected to a restoring force due to gravity that will accelerate it back towards the equilibrium position. Next, define amplitude. The maximum extent of a vibration or oscillation measured from the position of equilibrium. So that amplitude would be the distance or the length to which the object moves from the equilibrium position. So the maximum extent of a vibration or oscillation measured from the position of equilibrium is called as the amplitude. Next, define time period for simple pendulum. And it is the time needed for one complete cycle of vibration to pass in a given point. So the time period of simple pendulum can be considered for the movement of the simple pendulum from one extremity to the another extremity. So it is the time needed for one complete cycle of vibration. That means the pendulum should move to the extreme position and again come back to its initial starting position. So that would be one complete vibration or one complete oscillation. Next, what is meant by torsional pendulum? A torsional pendulum is a mass suspended on a string that rotates periodically. So the torsional pendulum can be considered as the mass that is suspended on a string that rotates periodically. When the mass of a torsional pendulum is rotated from its equilibrium position, the fiber resists the rotation and provides a restoring force that causes the mass to rotate back to its original equilibrium position. So in this way, the disc or the pendulum twists continuously. The shaft will be getting into twisting condition and the disc will move in to and fro motion from one extreme position to the other extreme position. Next, what is meant by compound pendulum? So any swinging rigid body free to rotate about a fixed horizontal axis is called a compound pendulum. The best example would be a steel rule that is hung against a wall to a nail. And when we give a movement to this steel rule which is hung against a wall, and the nail that is being used to hang this steel rule, that should not be at the centroid or center point of the mass or the center point of the rigid body or the steel rule. And then what happens? The oscillation which the steel rule will experience, it is treated as the compound pendulum. So this completes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.